Hi guys, this is 3.1c lesson, graphing with slope-intercept form, and I just want to say I fully intended to be present and doing this lesson in person with you guys, but unfortunately I woke up very sick. So we'll review the 3.1c extension next class, and we'll kind of review the homework a little bit if you guys have questions, but the good news is this is mostly review. So I think that you guys will really be able to do this. So we're going to start by plotting the point 6, 3. Go right 6 and then up by 3. That's my point 6, 3 right there. And then -9, -7. So now I go left to -9 and then down to -7 right here. And then it's asking me to form a line. Hopefully you guys have a ruler at home. I do not on this little digital, but we're going to form a line right here. And it says draw a right triangle on the line to find the slope, state the rise and run. So I'll review so far. I'm just going to go ahead and draw this triangle. And if I count my rise, it is from this point 3 to this point -7. So if I were to count that, that would be a rise of 10. And then my run is from 6 all the way to -9. So that would be a run of 15. And I just double check. This line is going in a positive direction. So my rise over run is 10 over 15, which that will reduce to 2/3. So right away, you might even want to label that as M because we are going to be using slope-intercept form, which is y equals mx plus b. So we already have the M right away. Now it says use the points 6, 3, and 9, -7, and the slope formula to verify the slope of the line. So that's asking me to actually plug in those points. And when I say plug in, I mean plug into the slope formula. So that is the m equals y2 minus y1 over x2 minus x1. Remember, you could also write it as y1 minus y2 over x1 minus x2. Either way works because the points could be flip-flopped, and this could be number 1 and this could be number 2, or vice versa. So my slope is, I'm just going to say start with actually 3 and then minus a -7 over, because I started with 3, I have to start with the 6 for the x value. Remember, the x value is always that first one in the coordinate point. So 6 minus a -9. So now that gets me 3 plus 7 and 6 plus 9, or 10 over 15. Same slope as I got up here. So that's what verify means. Examining your graph, what is the y-intercept? Well, because I didn't use a ruler on this and I didn't draw it very well, I'm actually going to use the slope, the reduced slope, to determine the y-intercept here. So I should be able to pick any point on this line and then rise by 2 and run by 3. So that's exactly what I'm going to do. I'm going to start down here at -9, -7, and rise 1, 2, and run 1, 2, 3. So that's a point there. Rise 1, 2, run 1, 2, 3. Rise 1, 2, run 1, 2, 3. Rise 1, 2, run 1, 2, 3, 2, 3, and it gets me to my other point. So see how when we don't use a ruler, we really cannot rely on the y-intercept, because it kind of looked like my y-intercept was -1, but it could have also been like -1/2. So my y-intercept here is 0, -1. Remember, we write it as a coordinate point. So now starting at the y-intercept, use the slope to plot a third point on the line. Well, we actually already did that. At the y-intercept, we rose 2 and ran 3, and this would be our third point there. Okay, so now it says, what is the equation of your line in slope-intercept form? So always just start by writing slope-intercept form. And then I'm going to write it in the simplest form possible. So my slope was 10 over 15, but we're going to write it as 2/3 simplified. And then when it asks me to write an equation in slope-intercept form, I always want to have a y and I always want to have an x. Okay, so the b was this 0, -1, because remember the b is the y-intercept. So I could write plus -1, or I could just write y equals 2/3 x minus 1. Okay. Now explain in words how the slope-intercept form is used to graph a line. Okay, so I kind of had to zoom out here. So first we plot a point on the y intercept. Oops, typos here. Then use the slope to find another point on the line. Okay, so we always start with either the given point or the y-intercept, and then we have to use that rise over run. And what's really important is that we use the rise to actually go up and down and not side to side first. Okay, this next part says rewrite each equation in slope-intercept form. Graph the equation by first plotting the y-intercept and then using the slope to plot the second point. State the slope, y-intercept, and x-intercept. So when it's asking me to get something into slope-intercept form, that means that I have to get the y alone. Okay, slope-intercept form is getting the y alone. So right now in number 2, 3 is being added to y. In order to get rid of it, I would just have to subtract 3. Then I just have y by itself on one side and 4x minus 3. So for number 2, I now have my slope and my y-intercept. So my slope is 4. And be careful for the y-intercept. When it's negative, we actually have to write it as a negative number. And I want you to write it as a coordinate point. So the y-intercept, x will always be 0. And then my y-intercept is negative 3. So we may be able to actually get the x-intercept from graphing instead of actually plugging 0 in for y. Remember, in the x-intercept, y is going to equal 0. So let's go ahead and graph. I'm going to start at 1, 2, negative 3, because that's my y-intercept. And then when I go up by 1, 2, 3, 4, and I only go over by 1 because my slope is actually 4 over 1. So that's my next point there. On my next point, I could go up again, 1, 2, 3, 4, and over 1. I could also, from negative 3, as at my y-intercept, I could go down 4, 1, 2, 3, 4, over to the left, negative 1, and I can go ahead and hopefully use a ruler to draw your line. So for the x-intercept, it looks like it's not going to be a whole number because that is not a whole number right there. So I'm going to actually have to plug in 0 for y. So y plus 3 equals 4x. If I plug in 0 for y, that will go away, and I can divide both sides by 4. So my x-intercept is actually 3/4. Okay, sorry guys, I had to pause there for my gardener, but this is actually a good time to pause and just remind you that you should be taking notes because I'm going to give you points just for following along in the video and taking notes. So you can always pause and go back if you didn't take notes on 1 and 2. These are free points here just for paying attention. So number 3, if you are feeling like you want to try this one on your own, go ahead and pause and try this one on your own. Okay, so my y is actually already alone in this problem, but usually we're really used to seeing slope on the left side and the y-intercept on the right side. This one's kind of trying to trick you a little bit because it's usually written like this. Oops, not as b, as 9. So we just need to rearrange it and make sure that we remember that our slope is actually that negative 1. When we just see a negative, that just means our slope is negative 1. When we just see an x, that just means our slope is 1. So my y-intercept here, again, I'm going to write it as a coordinate point. When x equals 0, y equals 9. And then I could plug in 0 for y to figure out what x would be equal to in the x-intercept. So if I did that, I would come down here, 0 equals 9 minus x. Well, if I subtract 9, I have negative 9 equals negative x. If I were to divide by negative 1 on both sides, that negative would go away, and negative 9 over negative 1 is actually just a positive 9. So that means that I could graph this in 2 ways. I could start at my y-intercept of 0, 9, and I could go down by 1 and over to the right this time, because remember, my graph is negative. I want it to be in like this direction. So I could keep going down by 1, over by 1, down by 1, over by 1. And if I kept doing that, it would actually get me right to my x-intercept. So when I have a slope of -1 or 1, my y and x-intercepts are going to be very similar. And I can graph right there. Hopefully it's a little bit prettier than my graph because you have a ruler in front of you. I do not. So that's it for that one. Okay, next page. Right away in this equation, you should notice that if I were to simplify and get y by itself, thinking back to module 2, and I asked, is this proportional or non-proportional? You would know that this was proportional, which means it doesn't have an initial value. That means my graph actually has to pass through the origin. Remember, when my y-intercept is 0, 0, the only possible thing that could happen for my x-intercept is for it to also be 0, 0. Because if I were to plug in 0 for y and solve for x, x would have to also be 0. Okay. My slope is that -3/4. So again, I'm just going to think, okay, I want my line to be negative slope. So I want it to look like that direction. So from here, I could go down by 3 and then over by 4. I could also go up by 3 and then over by 4. Make sure you don't actually accidentally do 4 over 3. It's a really easy mistake to make. So I could keep going if I wanted, up by 3, over by 4, which is a good idea, especially if you don't have a ruler. That allows us to see at least what points there are. Okay, and that would be my line there. So for number 5, it's starting to get a little bit trickier because we still want this to be in slope-intercept form and to get the y alone. So I have to think about how I would actually do that. For this one, I would first distribute that 5. So on the right side, I have 5x minus 35. And then the left side stays as 10y plus 15. I want to get the y alone on the left side. So I'm going to subtract 15 from both sides. And I'm going to just show my work down here. So on the left side, now I just have 10y because those 15s cancel. I have 5x minus 50 now. And then finally, I'm going to divide by 10. And remember, when we divide by 10, I want us to be dividing every single term on here so that we don't forget to divide any one of them. So 10 divided by 10 will just be y. 5 over 10 is also just half x. And then negative 50 over 10 will just reduce to negative 5. So now that's my equation in slope-intercept form. I have my y-intercept right here. That is 0, negative 5. So when I plot that point, it's on the negative axis, or I'm sorry, it's on the bottom of the y-axis instead of the top because it's negative. And then my slope is my m, which is just 1 over 2. This time I want my graph to look something like this because it's going in a positive direction. And remember, we always rise first, then run. So rise 1, run 2, rise 1, run 2, rise 1, run 2, rise 1, run 2, rise 1, run 2. So we were able to actually use the slope, and by plotting it super precisely, we now also have our x-intercept of 10, 0. So don't forget that we also need to draw this line. Okay. So sometimes you will be able to find the x-intercept by plugging in 0 for y. Sometimes you can graph it. If I were to go back and actually plug in 0 for y in this problem, so 10 times 0, that would go away. It would just be plus 15 equals 5x minus 7. If I were to divide by 15 on both sides, I get 3 equals x minus 7. X has to be 10. So either way, we'll get the same answer there. So at this point, if you want to try 6 and 7 on your own, go for it. They're a little bit different, but I recommend trying them on your own and making that mistake first so that we can kind of go over what happens here. So in 6, the first thing I actually noticed is that I have an x on both sides of my equation, which if we want to just balance this out, we can subtract x from one side, meaning we have to subtract x from the other. Both of those will go away. So I just have 2y equals 8. I want to get y alone, so I divide by 2, and my new equation is y equals 4. That original expression or equation that it gave me, it's actually the same thing. Y equals 4 is just the simplified one. The first thing that I think of is where on my graph does y equal 4? Well, it equals 4 right there at the y-intercept. It would also equal 4 right here, right here, right here. I'm literally just choosing random points where x could equal any number and y could equal 4. So my line will look like this. It will have a slope of 0. My y-intercept will be 0, 4. And I am never going to cross the x-axis. So my my x-intercept will be none. Okay. 7 is kind of similar. We'll notice that y is actually on both sides of the equation. So if I'm going to try and subtract y to cancel them, I just have x minus 3 equals negative 2. Now I want to try and get x alone. So plus 3, and I will have x equals 1. Oop, why can't I write the 1? X equals, okay, I don't know why I can't write that. There we go. Okay, so sometimes we can't actually get it in slope-intercept form because the y's will cancel. That's okay. If my y equaled 4 in number 6 was a horizontal line, the x is actually going to be a vertical line. So where x equals 1 is right here, and that would be my x-intercept of 1, 0. X could also equal 1 anywhere along this line. So I'm going to have a straight vertical line, and my slope is going to be undefined. Okay. My y-intercept is going to be none because I'm never going to touch the y-axis there. On this next page, it's a bit of a review of what we just did. So it says Janine was asked to graph the line x equals 1. She graphed the line on the coordinate plane but made a mistake. Describe Janine's error and then graph the line correctly. We literally just did this in number 7. So x equals 1 right here. That line that Janine graphed would be y equals 1. So I'm going to say Janine graphed y equals 1. So x equals 1 would be just a straight up and down vertical line. Okay. Number 9, Lonnie was asked to graph the line y equals 4/3 x. I'm going to write that this is m, or the slope, and minus 2. So this is my y-intercept, and I like to write it as a coordinate point of 0, negative 2. Lonnie graphed the line below but made a mistake. Describe Lonnie's error and graph the line correctly on the same coordinate plane. Well, let's start at the y-intercept of 0, negative 2. Okay, so Lonnie did that right. My slope is 4, 3, so it's positive, and it's going to go in the same direction as Lonnie's line. So I'm going to go up by 4, 1, 2, 3, 4, and then over by 3. Up by 4, over by 3. And this is not looking like Lonnie's line. I could also go down by 4 from the y-intercept. So 1, 2, 3, 4. Oops, 1, 2, 3, 4, and then over by 3. And my new line, or I should say the correct line, would look like that. So I'm going to say Lonnie's line. Let's see what Lonnie did. A point on her graph is right here. So if I draw a little triangle to find the slope of Lonnie's line, I go down by 3 and over by 4. So Lonnie actually graphed the slope of 3, 4. So I'm going to say Lonnie graphed using slope of 3/4, not 4/3. That's a really common mistake. That's why this module is giving you this problem, so that we don't make that mistake. Finally, Zach was asked to graph the line y equals -2x plus 4. He graphed the line but made a mistake. Describe Zach's error. So this 4 is our y-intercept. Let's see, we plotted. Perfect, we plotted that correctly. And this -2 is our slope. So already I can tell what Zach's error was. Zach graphed using a positive slope. Our slope was actually negative. So if he had just flipped his line around to look like that, it would have been correct. So Zach used a positive 2 as the slope, not a -2, which would have been correct. So that's it for notes. Please make sure that you do turn these into that assignment where that you found this video, because I'm giving you points just for completing this. And I will see you guys next class.